test for single proportion. To test the single proportion, the proportion means here the ratio. For example, if you want to find the proportion of people in a particular state who take rice, if you want rice eaters, by taking one sample, 1,000 pupils from X state, rice eaters if you take 1,000 people, out of 1,000, if 500 pupils take rice, the rice proportion is 500 by 1,000. So like that, one can easily evaluate the proportion X by N. N is sample size, X is how many people or how many persons are taking that particular product. Like that, we can easily calculate proportion for sample. The population proportion capital P may be given. Basing on that, we need to test. But how to identify? We have to apply single proportion test for the given problem, given data. So in given data, the technique is, if you have one sample without mean and SD, we prefer single proportion. As I said now, in a state there is a problem like this, in a state of some X or Rajasthan, out of 1,000 people, 500 take rice. Then can we assume there are 50% of rice eaters in that state? Then in the total state, 50% means for the total population 0.5, that is capital P. Now we need to check whether that capital P is 0.5 or not. That's why generally we take null hypothesis for single proportion capital P equal to 0.5. H1, if it is 2 tile, P not equal to 0.5, or 1 tile, P less than 0.5, or P greater than 0.5. This is one tile test. Coming to alpha level of significance, in general, it may be 5 or 1 or 2 or 10. Test statistic, which is formula test statistic to find Z calculated. Formula is small p minus capital P by root of PQ by N, where small p is sample proportion, that is X by N, small x by small n. Capital P is population proportion, small n is size of sample, and here capital Q can be calculated like this, 1 minus capital P. Now next we need to find Z table value as usual. Z table 2 tile and 1 tile. For 2 tile, alpha value directly we will take, 1 tile 2 alpha. So 5%, 1%, 2%, 10%. (1.96), 2.58, 2.33, 1.645. Here double 2 alpha means 1.645, 2.33. These values you need to remember. Basing on this value, you need to compare Z table with Z calculated. Then the conclusion is if Z calculated less than or equal to Z table, especially modulus Z calculated less than or equal to Z table except H naught, otherwise reject H naught. So this is the steps involved testing single proportion. This is single proportion test statistic. In a sample of 1,000 people in Karnataka, 540 are rice eaters and rest are wheat eaters. Can we assume both rice and wheat eaters are equally popular in this state at 1% level of significance? So that we need to test. If you read the question, nowhere you will find mean SDs. Only simple data, 1,000 people in Karnataka, 540 are rice eaters. One sample and one value is given. With that data we need to test. Whenever if you have this type of data, one sample and one value, we consider that one as single proportion test. And here equally popular, when we will say both two are equally popular, if 50% is one and another 50% is other, then only we say the both are equally popular. That's why we are taking H naught as capital P equal to 0.5, H1 capital P not equal to 0.5, and alpha given clearly 1%. That we are going to take. Capital P 0.5, capital P not equal to 0.5, 2 times, alpha given 1%, and test statistic, before going for test statistic, write given n equal to 1000, x equal to 540. Find out small p, x by n, 540 by 1000, 0.54 small p. Now write Z calculated, small p minus capital P by root of PQ by n. What is small p? Small p 0.54 minus 0.5 by root of capital P is 0.5, right? Capital P 0.5 means capital Q is 1 minus capital P 0.5. That is 0.5 into 0.5 by n value 1000. If you calculate, you will get Z calculated value. Use your calci to get that value, 2.53. Okay, now Z table. At 1% 2 tile. 1% 2 tile is 2.58. 2 tile 1%. Now Z calculated and Z table compare. Z calculated is less than Z table, so we have to accept H naught. That means the rice and wheat eaters are equally popular in the state. The proportion of rice eaters are 50%, the proportion of wheat eaters are 50%. Like that one can easily test single proportion test. 20 people were attacked by a disease and 18 survived. Will you reject the hypothesis that the survival rate if attacked by this disease is 85% in favor of the hypothesis that is more at 5% level? So whenever if you find this type of words, that is one type, more, less, you will get greater than, less than symbols in H1. So coming to the H naught, here we need to decide out of 20 people attacked by disease, 18 survived. So with that data, can you decide 85% were survived? H naught, what it says? A hypothesis of no difference. H naught says whatever we need to test, yes. So yes, 85% were survived. Capital P is 0.85. H1 more, greater than 0.85, one time. And given data, alpha is given 5%. If you come to given data, n is 20, x is 18. N is 20, x is 18. Now we need to find small p. Small p is x by n, 18 by 20, 0.9. Small p. And capital P is there. Capital Q 1 minus capital P, 1 minus 0.85, 0.15. Now test statistic Z calculated. Small p minus capital P by root of PQ by N. What is small p? Small p is 0.9 minus 0.85 by square root of capital P, 0.85 into 0.15 by N is 20. So now you will get Z calculated value. Use your calculator to get Z calculated 0.625 is Z calculated. Now find Z table. Z table for 5% one tile, 10% value you need to take 1.645 because one tile. One tile means 2 alpha. If alpha is 5%, in one tile you need to write 10% value. If it is 2 tile, 5% value, 1.96 you need to write. That values you need to by heart, that 4 values. Now compare Z calculated with Z table. Z calculated 0.6, Z table 1.6. So Z calculated less than Z table except H0. So that means yes, capital P is 0.85 is correct. 85% of people were survived by that disease. A manufacturer claimed that at least 95% of the equipment which he supplied to a factory conformed to specifications. An examination of 200 pieces revealed that 18 were faulty. Test the claim at 5%. Claim is what manufacturer said, 95% of equipment conform to the specification. But after selecting 200 pieces from that company, 18 were faulty. Then whether we can accept that claim or reject. What is the claim here? That claim we are going to take H0, negation H1, alpha percentage formula. Null hypothesis H0. Capital P equal to 0.95, 95%. H1. Capital P not equal to 0.95, 2 times. Because we don't have any information regarding null hypothesis, alternative hypothesis H1. Alpha 5% given and also given N is 200. But X is how many conform the specification? 18 were faulty. In 200, 18 faulty means conforming specification are 182. Now X is 182. Small p, X by N, 182 by 200 means 0.91. Okay, now capital P is there, 0.95. Capital Q 1 minus P, 1 minus 0.95, 0.05. Now substitute these values in Z. Small p minus capital P by root of PQ by N. Small p is 0.91 minus capital P 0.95 by root of 0.95 into 0.05 by N, 200. So now we will get Z calculated value. So Z calculated is minus 2.59. Whenever if you get Z value negative, take it modulus. Take modulus 2.59. So now compare Z calculated with Z table. Z table here 5% two-tile. 5% two-tile Z table value 1.96. Two-tile. So now compare Z calculated and Z table. Modulus Z table. Modulus Z calculated. Modulus Z calculated is greater than Z table. What we need to do? We have to reject the hypothesis. That means P equal to 0.95 is wrong. P not equal to 0.95 is acceptable. Any doubts you may ask? Test for difference of proportions. To test the difference between proportions. Till now we discussed a single proportion. Now we are going to discuss two proportions. For example, if you take a problem of rice eaters and wheat eaters problem. A state of some X state. So if you take a sample of 1000 people, one sample 500 are rice eaters. Another sample of some 1000, 450 are found to be wheat eaters. Now can you say the two rice and wheat eaters are equally popular in that state or not? Two sample proportions we can calculate. From that data we have two samples. From that two samples we can calculate two sample proportions. In that case we go for testing of difference of proportions. One small technique to identify that problem comes under testing of difference of proportion is, here you will have two samples of different sizes. There is no discussion about mean SD. No mean, no SDs. Just two samples related data. In that case we use testing of difference of proportions. In this, the procedure for testing difference of proportion, first write H naught, null hypothesis. Null hypothesis. H naught means null hypothesis. Step 1 is writing null hypothesis. After writing H naught, we are going to write H1. Next, level of significance alpha. Fourth, test statistic, which is formula for calculating ZCAL, Z calculated. So H naught is standard for testing of difference of proportions. P1 equal to P2. H1 may be P1 not equal to P2, two type. P1 greater than P2 or P1 less than P2, one type. Alpha 5% or 1% or 2% or 10%. Test statistic Z equal to P1 minus P2 by square root of small pq into 1 by n1 plus 1 by n2, where P1 is x1 by n1, P2 x2 by n2, and small p is n1 p1 plus n2 p2 by n1 plus n2. If you write in the place of P1 that value, P2 that value, you will get formula like this: x1 plus x2 by n1 plus n2. That is easy formula to remember. Small p formula, you can remember this instead of this. Actual formula is that one, so you can remember that one. Small q equal to 1 minus p. Small q is 1 minus p. This is ZCAL. Next, fifth stage, conclusion. In this conclusion process, you need to find Z table value. Z table values. That value, you know how to calculate Z table value. These values you need to remember. for every Z test, alpha, two-tile test and one-tile test. Two-tile direct value will take, in one-tile will take 2 alpha value. So here alpha 5%, 1%, 2%, 10%. So these values are like this. 5% direct value 1.96, 2.58, 2.33, 1.645. Here double. For 5% you will take 10% value 1.645, 2% value 2.33. Z table. Now by comparing Z calculated modulus less than or equal to Z table except H0, otherwise reject H0. This is a standard formula to decide whether we need to accept H0 or reject H0. Here you need to remember this is the formula. You need to remember these formulas. For every test, one formula you will have. This is fourth test in large sample test, last test. Like this you have 4 formulas. Replay when to apply difference of proportion. The manufacturer of electric equipment subjects to samples 2 completing brands. So indirectly he is mentioning there are 2 samples. Brands of transistors to an accelerated performance test. If 45 of 180, this is sample 1. Out of 180, 45 transistors of first kind and 34 of 120 transistors of, this is N2H2, transistors of second kind fails the test. What can you conclude at the level of significance 0.05 about difference between proportions? So the question is very clear. We need to do the test for difference between proportions. If the difference between proportions is not given in the question, how to identify? I said how to identify. There are 2 samples, unrelated data, but we don't have mean SDs anywhere. Then we think about difference of proportion test. Any test, these steps are standard. Writing H0, null hypothesis, writing alternative hypothesis, and writing level of significance alpha, and writing formula to calculate Z calculated. Next to conclusion. So first, H0 is standard for difference of proportions. That is P1 equal to P2. So here there is no information regarding H1. First brand is less than, second brand is greater than, like that. You don't have that type of information. If we have that type of information, then we take less than greater than in H1. So by default we go for 2-tile. P1 not equal to P2, 2-tile. And alpha is given 0.05 or 5%. Before going for test at stake, so first note down the given data. Given N1 and N2. N1 and N2 are 180 and 120. X1, X2 are X1 45, X2 34. With this data, calculate P1. P1 means X1 by N1, 45 by 180. P2, X2 by N2, 34 by 120. Small p, X1 plus X2 by N1 plus N2. That is 34 or 45 plus 34 by 180 plus 120. These values we have to calculate using using our calculator. So that information is clear. From the question we can get that total information. Any information you are having in the question. Now the P1 value, P2 value. P1 0.25, 0.283 and small p 0.263. Next small q we need 1 minus small p. 1 minus small p. 1 minus 0.263, 0.737. Now write Z calculated formula and substitute these all values. Z calculated P1 minus P2 by square root of small pq into 1 by n1 plus 1 by n2. P1 minus P2 we are having 0.25 minus 0.283 by square root of small p 0.263 into 0.737 into 1 by n1 plus 1 by n2. 1 by n1, 1 by 180 plus 1 by 120. If you calculate this value using your calculator, you will get Z calculated 0.578. Now we need Z table value for conclusion. Z table. Z table, fifth stage. Z table for 5% two-tile. 5% two-tile is 1.96. Two-tile 5%. No compare. Z calculated is less than Z table value. So accept H0. That is P1 equal to P2. Two proportions are equal. Okay. Two large populations, there are 30%, 25% respectively fair-haired people. Is this difference likely to be hidden in sample of 1200 and 900 respectively from the two population? Is this difference between that fair-haired people and normal haired people is hidden in these two samples or not, we need to discuss. That means whether the fair-haired people have same proportion in these two populations, in these two samples we need to test. For that the data is very simple. Two samples only given, N1 and N2. And X1, X2 is not there, directly percentages are given, proportions are given. Sample proportions P1, P2 are given directly. Whenever sample proportions are like this, the little change in formula we will do, that we will discuss in test statistic. But in every test, the testing procedure starts with writing H0, next writing H1, next writing alpha, level of significance, next test statistic, next conclusion. Formula test statistic means. Here we identified that this is a test of difference of proportions. H0 is standard for difference of proportions. P1 equal to P2, P1 not equal to P2 because no information regarding H1. That is 2 times, and alpha is not given. We take default value 5%. Test statistic, before writing test statistic, given N1 1200, N2 900 and P1 also given 30%, 30 by 100, 0.3. P2 25%, 25 by 100, 0.25. Now we need to calculate corresponding Q1 and Q2. Q1 is 1 minus P1, 1 minus 0.3, 0.7. Q2 1 minus P2, 1 minus 0.25, 0.75. Now write Z calculated formula. P1 minus P2 by square root of P1 Q1 by N1 plus P2 Q2 by N2. Now what is P1? P1 is 0.3 minus 0.7 by square root of P1 Q1. 0.3 into 0.7 by 1200 plus 0.25 into 0.75 by 900. So finally you will have Z calculated value. Use your calculator to get Z calculated. Minus 2.255 you will get. 0.3 minus 0. P2 0.25, right? Right. 0.25. So you will get plus 2.55 using your calculator. Now Z table, conclusion process. Z table 5% 2-tile. 5% 2-tile value is 1.96. Now compare. Z calculated is greater than Z table. So what we have to do? We need to reject the H0. So the two proportions are not equal, they are different. That is P1 not equal to P2. Accept H1. Okay? Any doubts you may ask. A cigarette manufacturing firm company claims that it brands A, brands A line of cigarettes outsells its brand B 8%. That means the sales between two brands of cigarettes difference is 8% given. If it is found that 42 out of a sample of 200 smokers they prefer brand A and 18 out of 100 smokers they prefer brand B. Now test 8% difference is a valid claim or not. So in previous problems the difference between proportions we need to test whether they are equal or not equal. Now the difference between proportions is 8% or not, we need to check whether it is 8% or not. That is, we need to use difference of proportions because we don't have mean and SD. We have two samples, 42 out of a sample of 200, N1, first sample. Second sample, N2, but we don't have any information regarding mean and SD. In that case, we go for difference of proportions. In difference of proportions, any test, first you need to write null hypothesis. Second step, you have to write alternative hypothesis. Third step, write level of significance, percentage of rejection. Fifth, write formula to calculate. Fourth one, write formula to calculate calculated value. Now, the difference is given. The difference between population proportions is 8%. 8% means 0.08, 8 by 100. So that whether we have to accept or reject. Is it valid claim or not, we need to check. The difference between the two brands of that cigarettes is 0.08 is acceptable or not, we need to check. For that, H1 I am taking not equal to 0.08. Whatever you write in H0, simply oppose in H1. If you write equal to in H0, write not equal to in H1. We written not equal to. If you write not equal to here, that is two-tail test. Now, alpha. Check whether alpha is given in the question. No. Whenever alpha is not given in the question, by default we take 5% is level of significance, rejection percentage. Test statistic. Before going for test statistic, First write given data. In given data, you have N1 and N2. N1 is 200, N2 is 100, X1 is this value 42, X2 is second value 18. And we need to calculate P1, X1 by N1, 42 by 200, P2, X2 by N2, 18 by 100. And small p, X1 plus X2 by N1 plus N2. X1, 42 plus 18 by 200 plus 100. These are all formulas. So in these formulas you need to substitute given data. Next you have to calculate P1, P2 values. P1 is 0.21, P2 0.18. Calculate using your calculator, you will get the answers. Small p is 0.2, then small q will be 1 minus small p, 0.8. Now coming to the test statistic, P1 minus P2, capital P1, capital P2, these two are small p1, small p2. Whenever the difference between proportions are given in the question, then the formula to calculate Z calculated is P1 minus P2, small p1 minus small p2 minus capital P1 minus capital P2 by square root of small pq into 1 by n1 plus 1 by n2. What is small p1 minus p2? Small p1 0.21, small p2 0.18. If you subtract p1 minus p2 using your calculator, you will get this value 0.03, and capital P1 minus p2 is given 0.08 by square root of small p 0.2 into 0.8, 1 by n1 200 plus 1 by n 200. Now you will get Z calculated value, negative value will get 1.02. If you get negative, take modulus. Whenever if you get negative, make it positive by taking modulus 1.02. Now this is calculation process, test statistic, finding calculated value. Finally conclusion. In conclusion stage, we need to find Z table value. Z table value for 5% two-tile. 5% two-tile, Z table. You need to remember these values. 1.96 because test is two-tile. Now compare Z table value with Z calculated. So modulus Z calculated is 1.02. This is 1.96. If you compare, modulus Z calculated is less than Z table. If Z calculated value is less than Z table, then you can accept H0. That is, the difference between the two brands is 8% is a valid claim. P1 minus P2 equal to 8% is acceptable, valid. That we need to test in the question. Whether that 8% difference is valid or not, yes. After testing, that difference is valid. Are you clear?